Hi guys, welcome to Learn Electronics Repair and the Signal Generator contest or competition. I'm sure you guys remember this. So this is a little signal generator I designed quite some time ago, and I put this on PCBWay as a project. They made me some PCBs and you can see them. So this is quite a small thing, and the intention was to make this small enough to build into a pen. Unfortunately, it was too big.
The pen was too small.
The pen was too small. The pen was too small. So here is a PCBWay pen. Yeah, this one actually has a signal tracer built into it, so it receives a signal rather than a signal injector. The signal injector required a little bit more circuitry. And unfortunately, you can see the one I designed is actually just a bit too big to fit inside here. Yeah, bear in mind that this gets narrower towards this end and that the inner diameter is less than the outer diameter. So that's the one I designed, and then this sat on one side for quite a while until I decided to resurrect it. So from the last video, the competition, design a signal injector using any method you wish, any circuit you wish, that fits inside a pen, a biro. And we specified the outer diameter to be about 10 millimeters, but bear in mind, you can see, in fact, the further up the pen, you haven't even got that. Okay, I'll just show you how big this one is.
10.
And this is exactly 10. Okay, so it needs to be smaller than that. Now, I have a little bit more information about this competition. Firstly, I asked PCBWay, and they tell me that the smallest PCB they can actually manufacture is 5 millimeters by 6 millimeters. That's tiny.
That's tiny, yeah.
That is tiny. Yeah. 5 by 6. That's the smallest they can make. And I also asked what the narrowest tracks they could put on a PCB are. And this applies to tracks and to spacing between tracks. And they informed me the narrowest track and the narrowest spacing they can manufacture is 3 mil. That's not millimeters, that's MIL. And MIL being 1,000th of an inch.
I think so, yeah.
Yeah, so 3,000th of an inch. But they recommend, for reliability and to keep the cost of production down, you have a minimum trace width of 6 mil. For those of you like me who are more metric, 6 mil, MIL, is 0.15 millimeters.
That's tiny.
That is also tiny.
Yeah. I mean, 0.6 is already very small. I normally run around somewhere 12 to 15 with normal signal layers.
Yeah, so that is small. So guys, those are the smallest tracks you can use if you use PCBWay to manufacture them, okay? And this video, by the way, is sponsored by PCBWay.com, so that would be nice. Of course, you can design your PCBs in any software you wish. But some of you guys commented that this is a little bit, not exactly unfair, but some of you are only used to working with through-hole components. You may not have good magnification to work on SMD components. So, to be quite honest, in the spirit of the competition, make the smallest through-hole version you can make, as long as it fits into a pen. And bear in mind, inside the pen, you've got quite a bit of space in this direction. At least 10 centimeters. So, yeah, if you want to make a small through-hole version, however you can, that fits in a pen, do that. Also, if you have some really innovative design, some really bizarre way of doing this, even if it's not the smallest, enter it. So we're not going to have one winner on this. We're going to have a look at everybody's entries. Everybody's going to get some respect for what they've done, and we'll have a look at all of them. And then maybe on a live stream afterwards, we can have a vote.
Yep.
Okay.
And everybody will learn.
And everybody will learn. And we're learning already. Even Det and myself learned something today. So I'm just going to show you the entries that I've had so far. There are actually 3 of you that entered. One put up 2 designs, the others put 1 each. And then Det and myself also have some. So if your entry is not being mentioned now in this video, it probably went into my junk folder. I did have a look in there. So if I haven't got it for some reason, let me know if you've made an entry and you don't see it now. Okay, so who entered the competition? So here we are on Tim's projects. Yeah, look at this, talking about my previous video. Okay.
You're looking at a YouTube video and a YouTube video and a YouTube
video. Wow. That can really screw with your mind. So don't think about it too much, guys. And Tim came up with two designs. One is using a 555 timer, and one is using basically the multi-vibrator circuit that I use with two transistors. But the most interesting thing that Tim came up with from our perspective was the battery. So Tim has a battery that effectively plugs into the top of the pen, and this is the battery. So CR425, 3.6 volts, so enough for microcontrollers. You can get these from AliExpress and other places, and they come with a little charger, so you get a little USB charger, plug your batteries in, charge them up, and then obviously you need to attach that to your project. In fact, you can see there where you plug them into the charger. This is obviously handmade, Chinese.
I would order one and never look inside how they're making because the first thing I said, how do they hold this inside the casing there?
Yeah, how is it held in?
Yeah, and Tim has a very creative
he does. So this is Tim's schematic, very similar to the one I built. And here, so this is showing how he's holding the battery in. And yeah, Det and myself were quite impressed. Look, he has like a little thing here made of two clips. He'll show you on the 3D view, and that's where the battery fits into the back of it. Look there, you see. So I'll link Tim's video. You can see he's explaining how he did this, but that's Tim's method of holding the battery.
Creative. I never would have come up with something like that.
No.
No.
And to be honest, we didn't know about these batteries.
No, I didn't. No.
So yeah. So now you all know, so that's one way to do this.
Yeah, learn something every day, guys. Learn something every day. Good job, Tim.
Yeah, nice one. Nice one, Tim. Okay, so that's one of the entries we've had so far. Okay, so here's another entry, this one from Thunder Ace. He came up with a design, again, same circuit I was using with some variations. The main interesting point about this is he has a double-sided version. He's using an A64 cell. Okay, which fits onto the board on one side. This is the other side. And again, he built a battery holder using a bit of Vero board.
Wow, guys, you're so creative with this, with using these things.
Absolutely,
yeah,
absolutely.
Brilliant.
Excellent again. I mean, guys, the battery doesn't need to be on the PCB. It just needs to be connected to the PCB. Yeah. Same with the switch, to be quite honest, if you want to put the switch at the end of the pen or something. Yeah, but that's really creative. So yeah, Thunder Ace, well done with that one.
Chris Land sounds German.
He does. German engineering.
See?
Point made. And this is Alex's design. So again, he has a very innovative way to hold the battery. Little clip there. And guys, this is a through-hole version.
Yeah, so for everybody who hates a surface mount, this is your version. Yeah.
Yep, absolutely. Once again, the schematic is basically the same as the one that I used. That's fine. And another really innovative design. Yeah.
Nice one.
Nice one. So, guys, those are the designs we have so far, apart from Detlef and myself. If you have submitted something and you've not seen it now, please get in touch and we'll figure out where it went to. And the rest of you, now you've seen what a few others have done, would you like to have a go yourselves? The competition is open, well, less than about a week or so into September. So at least another sort of 3-4 weeks you've got.
Okay.
Yeah. Okay. Okay, so that's some really inventive submissions by subscribers. And Detlef, you have something in mind.
Okay, let's go over to the thing. So when Rich told me about this, I slapped together a design with a battery, everything single-sided, and quite frankly, I hated it.
Okay.
And then, of course, I got thinking, as one does, and yeah, I did did things a bit different because all you guys using a stable multivibrators. I have a little chip on here, which is a tiny logic chip, and it's a inverting Schmidt trigger thing. Only one.
Only one. Yeah, this is like the little 5-pin gates we see on things like graphics cards and motherboards. So 2 inputs, 1 output, or 1 input, 1 output from the inverter, AND gate, OR gate. The size of these guys, I'll just tell you, is the same as an SOT23 transistor. So they're small.
Yeah. And why did I choose that? Because I wanted to do a different way. And an inverter with a resistor and a capacitor, there's your frequency generator.
Oh, very simple circuit.
Yeah. So I had some input filtering, some output buffering for getting rid of the DC for the signal. And you're asking yourself, damn you, where's the battery? There's none.
Ah, what do we have here?
These tiny things. I don't know if you can see this now.
We'll look at it in a moment.
Yeah, we'll look at this in a moment. These are photodiodes.
Okay.
What's a photodiode? It's something similar to a solar panel. If you remember back in the days and you had a calculator where it has this little solar thing on there, these were photodiodes.
Ah.
And these are 5 of them. So every photodiode gives me about 0.5 volts. So this should output something like 2.5 volts. The little tiny logic chip on the back of the thing should work at 0.9 volts.
Okay.
So we hope this works.
So these are like back to front LEDs. Like an LED, you input electricity and out comes light. And in this case, you input light and out comes the electricity.
Well, every LED, if we put enough light on there, is a photodiode. Yeah.
Oh yeah, this is true. This is true. So can we look at the schematic for this?
Oh yeah, of course. Well, there's not much schematic here. I got my photodiodes over here. 5. I'm guessing 5 would work fine. Could be that we can get away with 4. Could be that we need 6.
Yeah.
Buffering with a 100 nano, VCC and ground. Ground is one of the pads.
Okay.
Because I need to put this in the signal path somewhere.
Sure.
Yeah. There's my little Schmidt trigger inverting thingamajig. Which needs VCC and ground, and then some caps in here, some resistors in here, the output cap.
Why?
All the resistors are guesswork.
Yeah.
And you are asking why 2 of them.
Yes, in parallel.
Yeah, because I'm not sure what values I need.
Okay.
The Schmidt trigger should be doing the hysteresis of the Schmidt trigger should be something like 1 volt.
Okay.
But I'm not sure with that.
Okay.
So I'm guessing here, and I know the frequency this puts out when I get one.
Okay. Okay. So the idea is you can fit 1 or 2 capacitors.
Yep.
Oh, interesting. So, Jet, how big is this PCB?
Wait, let me show you the layout itself. So I'm coming down to 7.7, well, let's say 8 by 35, which is mainly by the photodiodes.
Sure. I mean, we have enough of at least 100 in the horizontal. That's 10 centimeters, so it's 3.4.
Yeah.
Yeah.
And, I don't need a switch.
Oh, of course you don't need a switch because,
I don't need a switch because this thing can keep running as long as
that's really clever.
This is a light depending function generator.
So you can only use the light if you've got a torch.
Yeah, or you got a torch. Yeah.
Okay.
Well, if you're measuring your circuits in the dark, this is not for you.
So let's have a look at these. Maybe we can get some voltage out of you.
Yeah, let's try.
Okay, let's go. Okay, so these are your photodiodes on a bit of variable.
I think there's some free floating around.
Okay, let's have a look. Photodiodes. So we have, I'm assuming, the positive and negative. Oh yes, there's a little red mark on one end.
Yeah, I think so.
Yeah, a little red mark on one end.
Yeah.
So those, yeah, you just put them in series.
Yeah, I dropped them on some variable board and you put them in series to see what I get out of this.
Okay, so it doesn't require a resistor like to limit current because it will supply just whatever it can, I take it.
Yeah, that's the point, yeah.
Okay, let's measure the voltage coming out of this. So I'll connect, and this is just with the lighting on in the workshop.
I measured in the sun 2.5 or 2 volts or something. I can give you a bit more sun. Oh yeah, I'm getting closer. So
Half a volt.
half a volt is not that much.
No. I think you need more diodes.
Wait. Let me try this.
0.7, 0.6, 0.7.
Okay. Well, we maybe want to try this in the sun. Maybe this is something that only works in the sun.
Outdoors. So outdoors you were getting about 2 volts, yeah?
There's an out. Yeah, I tried this on my bench at home.
On your bench?
Yeah, at home. And,
With sunlight.
With sunlight, yeah.
Okay, so that's Det's work in progress, guys. But there we are, a work in progress.
This is work.
Maybe you need more diodes.
Yeah, this is absolute work in progress, and I have no idea if this will work anyways.
Okay, well, I'm sure you guys out there will have quite a bit to say about this thing in here. So get down there and let us know.
Yeah, but I love the idea to do something different and get rid of the battery, because the battery was nagging me.
Absolutely. Okay, guys, so that's a work in progress. Can we do without a battery? Okay, guys, and then there's my version. So quite independently, I went down a slightly different route. I found some smaller batteries that were actually narrow enough to fit inside the pen, but to be quite honest, I may now use the ones that Tim came up with. Yeah, for whatever reason, the batteries arrived and they are somewhere.
Gone where batteries go.
Yeah, gone where batteries go. So this was my version, and I had a look to see how small I could actually make this. So this is a schematic of the one I originally built, and while I was playing around, I was looking at building PNP versions of this as well. And in fact, you can build a PNP version. You just change the transistors to PNP and switch the power supply. Everything else stays the same. And to make it smaller, I decided to use a double transistor. These things. So we need to get a bit of magnification on this.
You do need to, yes.
There. So this is, I believe, SOT363 it's called. It's slightly smaller than SOT23. Okay, and it has 6 pins. And inside there are 2 transistors. And you can get these either NPN or PNP versions, and they're cheap and easy to get. I had a look at a few easily available ones. So MMDT, this means double transistor, by the way. 5551 or MMDT3904. This is the pinout, or for PNP, MMDT5401. You could use that version. Because this is outputting AC, it doesn't really matter if it's NPN or PNP.
Sure.
Yeah. Now, the interesting thing with this, you'll see the way it's laid out. So you have base of transistor 1, emitter of transistor 1, and then the collector's on the opposite side. Yeah. Base of transistor 2, emitter of transistor 2, and the collector is on the opposite side. Now, my first thought, hey, that's great, because the collector's on the opposite side of the chip. It's easy to connect base of 1 to collector of 2. This crossing over you have as part of the circuit is no longer an issue.
Yeah, and you can do this there and there.
There and there, yeah. So literally your capacitor can go there and there.
Yeah.
And then you just have resistors. So I thought, hey, they designed that perfectly for this. And then I realised they didn't design it for that reason. The reason they designed this way is because there's no pin 1. You can put the chip either way round and you get the same functionality.
Yeah. Which is also clever, yeah.
Which is also clever. So that's it. So I'm just going to show you my version then of this. And here is the schematic. So you can see it doesn't actually matter which way round you put this chip. It always works the same. There is your capacitor between collector of 1 transistor and base of the other. So it means that all the components are on either side of the device and there's no crossing tracks. And to me, that was a godsend. It makes it much easier to make the layout of this.
Why did you choose in the 1220 and a 150K?
Okay, right. The original design that I took off the internet on one of the popular sites, I can't just remember which one it was now, had 220 and 150. Now, normally you would have them both the same value. But I went along with what they'd done and it worked fine. It alters the duty cycle a little bit of the wave.
Yeah. And it maybe biases the thing to start swinging.
Yeah, maybe. Or it may, because it's not 50-50, be generating more harmonics, because the whole point of using a square wave is generating harmonics. So it may be that this design generates more harmonics. But yes, you can put the resistors the same value. I just went along with the original design. I think it was like Everyday Circuits or one of these sites you find. So that's where it came from. So that's why they're different. This then, because their layout is so easy, comes to this. And you guys may be surprised. So the PCB is 5.58 millimeters wide. And the length is 14 millimeters. It's tiny. Now my design doesn't have the switch and battery mounted on the PCB. I could make it longer, I have the space, but I think it's probably better for when I played around with a Vero board version to actually have the battery mounted off the board. Okay. And that's mounted to a little board that effectively has a switch that pokes through the outer skin of the pen, basically.
Yeah.
So that's the smallest I can make. I'm sure this can be compressed further than that. I'm now using 0402 resisting capacitors. I'm not using 0201 because they're a pain in the ass to solder, basically.
Yeah, I believe that.
0402 is just that little bit easier. And the thing is well within the dimensions of fitting into a pen. So kind of like, why do I need to make it smaller than that?
Yeah, my first reflex was to say to Richard, you can make it smaller, use both sides.
Yeah. So
but this probably makes it more fiddly to solder.
Yeah. So for you guys interested in building or working on this version, you know which transistor device to use. You could make a version of that with components on both sides. Yeah, and get it smaller. Again, the competition is open to all of you. As long as I can solder the thing. The thing with this, I can actually do this on a hot plate because there's no components on the back. It's just It's just easier for me to build. So that's my version of it. And guys, you may think that is the end of this video. So on Sunday afternoon, I sent Det maybe a strange message because I took a siesta. It's been very hot here, by the way. High end of the 30s. It's really warm. And the best thing to do in the afternoons is just go and lie down. So
siestas are underrated.
Siestas are underrated. Yeah, guys, should really try a siesta. So I woke up, this was more of a 4 p.m. moment than a 4 a.m. moment. And I thought to myself, what's the smallest Bluetooth audio receiver we could get? Because how about making a Bluetooth signal injector pen? So when I got up, I had to text Det, say, are you awake yet? Have you had your siesta? Asked him the question. He said, what are you trying to do here? So I described effectively an audio receiver that connects via Bluetooth to your laptop or computer or whatever, and now you can send whatever you want to the thing via Bluetooth, whether it's a continuous tone, square wave, sine wave, triangle, whether it's music, and you can inject that into your device on the test. And so Detlef, well, he's brought this in. So this
test the signal injector.
To test the signal injector. So this is Bluetooth 5 audio. It has a headphone output.
Yep.
There. So it's USB, headphone output, and you can connect a probe to there and use it as an injector. But we don't know a few things about this. Is it isolated from like the USB? So any ground that you might connect to this to your device on the test, is it grounded to the USB? Admittedly, USBs tend to be isolated supplies anyway. But
well, you could always use a power bank, then you're sure.
Yeah, but if you had it plugged into your computer, that might not be the case. Yeah. And secondly, does the audio signal coming out have any sort of isolation like a capacitor? And anyway, that won't fit into a pen.
No, not really.
But we found something that we think will. And the great thing of having a friend like Detlef is once you feed an idea in, he just has to have a look at it. Yeah.
Yes.
And Detlef came out with this one. So these little modules, you can buy them from AliExpress. And this is a Bluetooth receiver on a PCB. We can see the Bluetooth antenna here. We can see a handful of resistors and capacitors. Notice 2 of the resistors are actually 0 ohm. They just use as bridges over tracks. There are a few tracks on the other side, and an oscillator and a chip. Okay, this is a small outline IC, SOIC, 16 pin. And this is a Bluetooth receiver. We've tagged some wires on because we were interested to see what voltage this needs to run. And I connected to my bench power supply at 3.6 volts. We switch it on and this appears on Detlef's phone as a Bluetooth device, audio device. So this would run from the battery that Tim has.
Yeah. Any LiPo cell would be happy with that because the listing on AliExpress says this is a 5-volt device. So probably it runs from 3.3 to 5 something.
Yeah,
so
it moves that way.
Yeah, so you're good with anything LiPo.
Yeah. Now this is too big to fit into a pen. But if we have a look, we see the chip itself with the spacing of the legs is about 8 millimeters. 7mm actually. I look at the capacitors. So it's about 7mm across. So an 8mm PCB or 7.5 would fit that chip, and we have quite a bit of room in that direction. So if we can route with some narrow tracks and get the various capacitors and resistors kind of down here, we think we could get that to fit into a pin. The problem is that this chip in particular, we can't find a datasheet for it. And it's, we think, is a programmed device anyway, because it comes up with some sort of Bluetooth ID.
Yeah, you can, in the factory, you normally set the Bluetooth ID for this. So it has a name, the name you see on your Bluetooth connection then.
Yeah, so even if we could get the chips, which we don't actually know what they are exactly, we may have problems programming it. And Detlef came up with the idea, and I think it's absolutely excellent. The first thing I said is, well, we need to reverse engineer this schematic so we know how to position the components. And the second thing I said is, to do that we probably need to unsolder the chip off the board so we can see if any tracks go underneath it or anything else. Looks like, yeah, probably no vias under there as such, but certainly tracks. And then Detlef was saying, well, you can buy these. How much are these things?
5 pieces is under $4. $4
for 5 pieces.
Yeah.
So Det came up with the idea of, we reverse engineer the schematic, we make our own very long and narrow PCB, and instead of buying the components, you just buy one of these, unsolder the parts, and solder them on your PCB.
Yeah, and Bob's your uncle.
And Bob is your uncle. So we're going to give that a go, guys. But if any of you guys are interested, I mean, you know, we're giving the information now. If you think you can find a smaller one or you want to have a go yourselves, feel free to do so, yeah. And what do you think? Bluetooth signal injector, would that be useful?
Well, the one point is, of course you could use a PC, but separate power
Like a battery?
Like a battery with a separate battery. You're not connected to any ground from your PC, so you maybe save your PC from blowing up. Yeah, you're absolutely isolated from everything by the Bluetooth. Also, we mentioned the antenna, which we can see connects via a capacitor onto this chip. With a double-sided board, the antenna can be behind the chip. No, it can't.
Be close.
It can't. It can't.
It can't. Okay.
It needs. You see the turn around again. You see the. I'm pointing at the screen here. So wait, let me show you that. You see where the ground plane ends here.
Yeah.
You need to leave space beyond the antenna, and on the other side is the same. Turn around.
Okay.
See where the ground plane ends.
Yeah, I see where the ground plane ends.
This must be. Nothing under there, no tracks under the antenna.
Is there any reason why the ground plane needs to go all the way under the chip?
Well, you normally do this.
Okay. So we have to consider the placement of the antenna, maybe to one end of the chip, and then the components to the other end. Yeah, components. So that's what we're thinking, guys, and we think we can get this. And like we say, isolated, you can inject anything you want, whether it's just tones or whether you want a sweep generator.
Sure.
In generators, yeah. Get a sweep going in on Bluetooth, get music going in, anything you want to do. Yeah. So that's where we are at the moment, guys, with it. Very interested to know what you guys think. Comment down there. If you want to run with any of the ideas you've seen here today, free to do so. So thanks for watching, guys, and we look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now.